Today's Daily Dose of Math is about doing a scale drawing of an object. I'm going to be drawing this object right here. It's a little external hard drive. And it's a rectangular prism. It's a box. It has a length, width, and a height. But which is the length, which is the width, which is the height? Let's talk about that first, using this other object. This is a box of chalk. And if I was laying this on a shelf, I would say, here's my length, the longest of the three measures. Here's my width, the medium one, and the height is the shortest one. But this is designed to hang from a hook. So if I look at it in the store and it's hanging from a hook, I'm going to think that this longest measure is actually the height. Height, width, and length in a rectangular prism are sort of interchangeable terms, depending on which side you feel like putting on the bottom. Back to our object that we're actually drawing. I'm going to let this writing and logo tell me which is the top. That means that this biggest face is the top. And that's going to make me choose to make this longest measure the length, the medium measure is the width, and therefore this smallest measure is going to be my height. That's how I'm going to look at it when I'm deciding how to show the top view, front view, and side view. The next decision is about scale. This is a pretty small object, and I'm trying to draw it on a very large surface because I'm making a video and I want students who are watching the video to be able to see what I'm drawing. So I'm going to make the drawing bigger than the object. I think I'm going to draw it at a 3:1 scale, meaning 3 centimeters on the drawing will represent 1 centimeter on the object. And the object will end up looking 3 times as big in the drawing as it does when you see the real object. So I'm going to write my scale 3:1 like this. Now the way this scale is given, there's no unit of measure given because it means 3 centimeters represents 1 centimeter. Since they're the same, they're both centimeters, you don't have to write a unit. That means 3 millimeters in the drawing represents 1 millimeter in the real object. Notice that the top number is bigger. Most drawings that we look at have a tendency to be on an 8.5 by 11 inch piece of paper and can often be of our objects that are much bigger, like a house or a car. So necessarily the drawing has to be smaller than the real object, and when that happens, the numerator of this scale ends up being the smaller number. But when you see a scale with the numerator as the larger number, that allows you to realize, oh, okay, this drawing is actually bigger than the real object. A good example of a time when that's necessary is when you are designing a piece of jewelry. A piece of jewelry like a ring is quite small, and if you try to draw it life size, you have a little drawing like that, it's hard to show very much detail. So instead, we draw our ring much bigger than the real object so that we can see in the drawing the dimensions and the details that we want to be seen. Okay, my next step then is to measure this object. Okay, I'll start by measuring what I'm calling the length. And I'm going to call that 12.8. 12.8 centimeters. Now the width .3, and then of course the clumsiest one will be this one. Hard to show. I'll do it like that. A little shaky, but I'm calling this 1.3 centimeters. Now that we know our measures, I'm going to write them down over here. 12.8 centimeter length by 8.3 centimeter width by 1.3 centimeter height. Now, we want to represent those with a 3:1 scale, which means I need to triple each of these for my drawing. Now, let's think about the views. Top view is going to show this. It's not going to show this little height, so I don't need the 1.3. So what I'm doing is I'm taking the length and the width and I'm tripling both of them. I need a 38.4 centimeter line to represent the 12.8 centimeter length. And I need a 24.9 centimeter line to represent the 8.3 centimeter width. I'll do the width first. I need 24.9. This ruler shows 30 centimeters. And there we go. I've drawn a 24.9 centimeter line, but it represents 8.3 centimeters, and I label with the real measures. That represents 8.3 centimeters. Now I need a 38.4 centimeter length. This thing, the top of it is a rectangle, so I'm drawing a 90-degree angle. I am drawing it by eye. The ruler only goes to 30. I have my length, and it's not really 38.4 centimeters the way I drew it. It's 12.8 centimeters on the real object. Now I need to draw the other two sides, and then I'm finished. So we have drawn our top view. Someone looking at this drawing can tell that the top view of this object is 8.3 centimeter by 12.8 centimeter, and it's a rectangle. They're going to be able to see the shape of the real object from the drawing. That's the point. Now let's look at the front view. The front view is the one that has the longest measure and the shortest. It's the 12.8 and the 1.3. I have to do a calculation for the 1.3. 1.3 centimeters times 3 equals 3.9 centimeters. So I'm drawing a rectangle that is 38.4 centimeters by 3.9 centimeters. I have less space to work with because I need less space. I need to draw one of these lines again. That's the 12.8 centimeters. Now I need the 3.9 centimeters. Not very long. But that's the whole point. It represents the real shape of this object, and this thing is not very thick. Let's finish the drawing. And we have our front view. I have to label this side. It's really 1.3 centimeters. I have enough information for the person who's looking at the drawing to understand what this would look like. And now I'm going to do the side view, and the side view is going to be the 8.3 by 1.3, so I need to draw 24.9 by 3.9. Now I have to admit that most of the difficulty of drawing these is the fact that I'm trying to draw them on a shaky whiteboard. And doing this on a piece of paper would be a little bit easier. I still have to label. I need the 8.3 centimeters. I'll put it on the bottom here. By the 1.3 centimeters. One bit of information that's still missing from these diagrams is the angles. This is a rectangular prism. All of the faces were rectangles. So I'm going to show the little square symbol that shows we have 90-degree angles. And I'll just show it on all of the corners of these rectangles. Not so easy to show when you have such a skinny diagram, but I still managed. And someone who's looking at this diagram has all the information they need to understand what the shape really looks like. So what's involved in doing this? We need to understand the concept of top view, front view, side view. We have to know how to show our scale. It's helpful if we understand that when we draw something larger than the real object, the numerator of the scale will be bigger. We label with the real measures, not with the drawing measures. And we apply the scale in order to figure out how long we have to draw the sides in the drawing. That is today's Daily Dose of Math. Please like, subscribe, and share.